Welcome back, students. This is the session 31 from the playlist of JEE Mains Part 2. The topic is magnetic field due to a current carrying loop, and this question which I have taken for this session was asked in the All India Engineering Entrance Examination, that is AIEEE, in the year 2009. Here the question is the magnitude of the magnetic field at the point O due to the current carrying loop is. So there are four options given here, and we have to find the correct one. So this is the current carrying loop. A, B, C, D is the current carrying loop in which the current I is flowing, and O is the common center. O is the common center of the circular arc AD and BC. The radius of the arc AD is A, and the radius of this arc BC is given as B. So now this is a very easy question, and it is based on a very simple formula, and that formula I have already written here in order to save the time. The first thing is that let us know what the formula is. So the formula for the magnetic field due to a circular arc carrying a current I is given by mu naught I upon 2r theta upon 2 pi, where theta is the angle subtended at the center of the arc. So in this case the value of theta is equal to 30 degree, and this theta has to be in radians. This theta has to be in radians. Now we know that 180 degree is equal to pi radian. So 30 degree will be equal to pi upon 180 into 30. So this is equal to pi by 6 radian. So this 30 degree, if I write it in radians, this will be equal to pi by 6 radian. Now the magnetic field at this common center O, this is the common center of the arc AD and BC. So the magnetic field at this point O, this will be equal to the sum of the magnetic field due to this arc AD, segment AB, arc BC, and the segment CD. So this will be equal to the magnetic field due to this arc AD, which I am writing it here as BAD, plus the magnetic field due to the segment AB, plus the magnetic field due to the arc BC, plus the magnetic field due to the segment CD. So now we have to simply find the magnetic field for each arc and the segment, and then we will add it up in order to get the total magnitude of the magnetic field at this point O. So now the magnetic field due to a circular arc which is subtending an angle theta at the center and carrying a current I is given by mu naught I divided by 2r in bracket theta upon 2 pi, where theta is in radians, so which is equal to pi by 6. So for the magnetic field due to this arc AD will be equal to mu naught I divided by 2. Now in this here r is the radius of the arc. So in this case, that is in the case of arc AD, it will be equal to A, and now theta is equal to pi by 6. So I will be putting the value of theta is pi by 6, and this will be into 2 pi, plus the magnetic field due to this segment AB. Now here in this case, in the value of this theta will be equal to 0. Therefore the magnetic field due to this segment AB will be equal to 0. Now we have to find the value of the magnetic field due to this arc BC. Now the direction of the magnetic field is can be found with the help of the Fleming's right hand thumb rule. So since you can here see that here the direction of the current is pointing upward, and in the case of this arc BC, the direction of the current is pointing downward because the current is flowing in this clockwise direction. So in this case, in the case of this arc BC, the direction of the current is opposite. So here, since the direction of the current is opposite, therefore the direction of the magnetic field will be opposite to that which is generated by this arc AD. So here in this case, I will be using, since the now magnetic field is a vector quantity, and since the direction of the magnetic field generated by this arc AD and BC are opposite, therefore here I will be using the minus sign, and this will be equal to mu naught I upon I will be writing it here. That will be equal to mu naught I upon 2b in bracket pi by 6 into 2 pi plus 0, because the magnetic field due to this segment CD will be equal to 0, because in this case the value of theta is equal to 0. So finally now we have to simply add it up, and we will get the value of the this magnetic field at the point O. So this is the magnitude of the magnetic field at the point O will be equal to mu naught I divided by this pi and pi will get cancelled, so this will be equal to 24a minus, here pi and pi will get cancelled, so this will be equal to mu naught I divided by 24b. Okay. So finally, the magnitude of the magnetic field at the point at this common center O will be equal to I will be taking here the LCM. You can take as 24AB as a LCM. So I will be getting mu naught I B minus mu naught I A, and this can be written as, here mu naught I is common, so mu naught I in bracket B minus A divided by 24 AB. So the magnitude of the magnetic field at the point O is equal to mu naught I divided by into B minus A in bracket divided by 24 AB. So here the correct option is B. The correct option is B. So here in this case, the most important thing was that apart from remembering the formula, the most important thing which you have to take care of is the direction of the current, because the direction of the current is reversing. Therefore, the direction of the magnetic field due to this arc AD and BC will also be opposite, and therefore we had used this if I have taken the magnetic field because of this current carrying arc AD as positive, then the magnitude of the magnetic field due to this current carrying arc, that is BC, will be taken as negative. So by using this concept, we were able to find the value of the magnetic field at this point O due to this current carrying loop. So thank you very much for joining in this session, and in the next session I will be coming up with a different type of a question which has been asked either in the IIEEE examination or in the mains examination, and this is the first session from the chapter of the magnetic effect due to current. There is a chapter by the name of magnetic effect due to current. So this is the first session from this chapter. So I will be taking maybe 15 or 20 questions which has been from the JEE mains examination and from AIEEE. And so till then, have a nice day. Bye.